Okay, I've decided to make this a two-parter also. Uh, I like to spend a lot more time on this last iteration of this seven test lines. I think there's a lot can be learned from coding techniques and ease of use. So why don't we just get started here. Let's move over to another screen here if we can. Okay, this one, the results are going to be the same. The screen's going to look the same when we're done. We're going to put some options to it though. So all the top part is the same as the three previous were. All this is all the same. It's all the same. All the same. This here, our subroutine, this is all the same. The one place we get is down here is we added a main loop in here, as we've done in the past. Get a character. If there's no character, keep looping through main loop until you press a key. If you do a Q, it's going to be quit or done, whichever you prefer. If you put a B in there, is the blink option. We'll be able to make a line blink, or N to no blink, and T will be change a text message. If we don't get any of them, we branch the main loop until we get one of these good valid input keys. So let's look at the first one. Well, the first one is Q. It is branched to done when we're done. That one's easy enough. Next one is the B option for blink. So we're going to put in here option of do blink. We're going to load up a line. Now this is all hard coded just to work with this one line. It'd be more complex to sit in here and ask for which line you want to change. Save that. But for simplicity, and try to get through this, we're going to use line 4. What line do we want to blink? Line 4. Then we're going to branch subroutine to add blink. Okay, let's get down here to. Okay, I guess probably need to stop right here. Here's what we got. Let's look at our lines again. Let's look at line 4. We have our column, our rows, our attributes, and our line. You could consider that to be an object. In a sense it is, because it's contained of everything we want for that line is contained right there. So we're not going to be like an object when we're talking about C++ and that, but polymorphisms and all the other stuff goes, what this is an object. All right, and our object has in it column, it's spaced in the first position, row is in the second position, attribute in the third position, and our message starts in the fourth position. Remember, base 0, so we start 0 through 3. So in our blink, we'll load up branch subroutine add blink. We load A with the attribute based on what register U is, position 2. We OR A the blink option on top of that. Again, you need to make sure you understand what OR does. You go back to Steve Bork's course and you'll see exactly what OR does. It's just saying whatever's already in that attributes, just say it was yellow and black. We're just going to add the blink option to it. That's all we're doing. And we store that back into the object at the attribute position. And we return sub. All right. Branch sub, we added that. Now it says branch to do all. So all these routines are going to do the same thing. They're going to reprint the line on the screen because we changed the attribute. We'll reprint the line and we'll move the cursor back down to the bottom of the screen. If we don't do this here and we change line 4, that's going to leave the cursor sitting at the end of line 4. So when you do something else, it will just be in the middle of the screen and arbitrarily mess up your screen. All right. Now our no blink option is basically the same thing. Load what line we want, branch subroutine, delete blink, and that's going to do the same thing. It's going to load up our attribute. Now this one here, you notice I didn't up here I use object attribute, and down here I hard coded as a 2. both compile to the same look. Let's look at that. Okay, up here was our object attribute, comma U, and that's what it compiles to, A642. With the hard-coded 2 in there, it's A642. Exactly the same results, regardless if you use however you use it. Right, when we get it in there, we're going to and A, and means, again, you need to make sure you understand all these instructions, what they do. Not is a hex FF. That means I don't want to change anything that's in there, any attributes in there. All I want to do is minus the blank. So that gets rid of the blank option. We store that back down, and we return back. Just like we did on the other one. The reason I did this here is to explain, if you do it the hard-coded way and you decide you want to change your program for whatever reason, okay, this is a very simplistic program here, and what I'm calling our object is very simplistic. But if we decided to add something to this object, regardless what it is, this could be something, we have names and addresses, it could be an inventory for a plumbing supply house, it could be anything. And we decided we needed to add something. Well, you could always say, well, just add it to the end. Well, that's fine and dandy, but with ours, we have everything as a fixed link in here. All of our test lines here, messages, are all fixed length. What if it was a name and address field? Okay, everybody's name isn't the same length. Their addresses aren't the same length, so this part would be variable. So adding it to the end, we would not know exactly where the end of it is. So we would have to add it somewhere prior to the message part. Okay, we'd have to add it somewhere. We'd have to add it somewhere above this, okay, because this one here is not fixed. So if we was to say we was going to add it right after a row, whatever it is, we just call it stuff. Okay. Okay, and then we'd have to change this one to 3 and this one to 4. Okay, we'd have to change that and then recompile. And everything would be fine by just changing that. But this way here, we would have to go through any place in our program that we hard-coded it and manually change all that. This is another coding to ease of maintaining it in the future. So very simple object we have here, but a complex one. You can see where you could run into a lot of problems by hard coding. Code it correctly up front, take the time to do this, you won't have them problems at the end. Wait, just a recompile and everything will be fine. Okay, the other option we had was new text. This one here is also going to be hard coded. We're going to load up 4, load the address of our message, a current message in here, which in 4 it would be right at the beginning of this test line 4. And then we're going to load up Y with our new message. Okay, right here is our new message. Okay, it just says new text. All right, we'll load up the length of new message. Well, how do we know what the length is? Okay, well, it's right here. Here's this is the way this lets the compiler take care of it. We're going to equate it at asterisk, which means right here minus the beginning of new message. So it takes the end of it minus the beginning and calculates it out, and you can see it over here. It comes out to be 14 characters long, or hex E. We load up our new message length, and we just do the normal loop like we always do. We load up one character for the new message and store it in the old character. Subtract 1, if it's not 0, loop through 14 times. Then we branch up back to that all routine, was branch all, wherever that was. I don't remember where it was even. That will move us down to the end of it, and we'll be done. Now, the problems with some of this, the way we're doing it, this is all nice, it's for simplicity. again, if this here new text, if that was, let's just say we had city state, and this was the city, and the city that you lived, put in there was, we'll just say, let's pick one out, Chicago. We know how long Chicago is. You know, we count on your fingers and say this that many characters. Well, if the new city you're putting in there is something like Jefferson City, Missouri, or Apalachicola, Florida, you should in your code test to make sure that it isn't longer than what this current field we've set up here. Right now we've set it up to be 14 characters. And if you put Apalachicola in there, it would never fit and it would override the next one. So this is simplistic code because we're doing everything that we know the fixed length of. So your code would have to test the new message coming in, which is far from what we're trying to do now. We're trying to keep it as simple. And I hope I'm not overcomplicating. I'm just trying to show you things we need to learn how to do is these tables, these what I'm calling objects. Because this is just some text stuff. We could be using column row, but we could be having a starship on the screen, and a graphic screen. And where is it? How's it moving? We'd have to have a control byte and says how many missiles does it have left to fire? How many, or it could be anything. Okay, it's just they're all going to work in a similar way. You're going to have your own object for each individual thing you have on the screen. So I guess enough babbling about that stuff. Again, I don't know if I've confused you or not. Go back, re-look at all the stuff that I've put out there, and especially, I'm going to put it in again. I'll put it in the link at the bottom of this, Steve Bajork's code, to tell you what each one of these instructions do, because until you learn what these instructions do, the rest of this is just all Greek and hieroglyphics. So go through his stuff one or two times if you have to. Go through mine one or two times. Other stuff you find on the internet. I'll put all this source code again in a zip file. You can download it. And just taking that zip file, that source code, compiling it, and running it and say, whoopee, I'm going to assembly language program. No, all you're doing is just compiling my stuff. You need to change it. How can you change it? You might want to do things like ask for what line number do you want to change. Remember up here we said we'd hard code line code 4. You might have just try. I mean, you're not going to hurt anything. Put another option in here. Ask what line number, and then figure out somewhere. Well, if it's a 3, how would I do that? You may not figure it out, but at least you'll try. Trying is the only way you'll ever learn assembly language program. Same way if you do basic programming, the only way you learned how to do it was trying it. You're not going to hurt anything. It's just you could embarrass yourself. You won't be embarrassing the rest of the world, but you say, oh my gosh, I should have done that. Anyway, here I am rambling on again, but I'm trying to make sure that all you young, you don't have to be young, but all you people that want to learn assembly language program, you don't learn it by copying my code. You learn by take my code, someone else's code, and changing it. Look, ask questions. I'm going to put an email address out there. I've got no questions in all the stuff I've ever done, a question on how does that work. So I'm assuming that there's nobody looking or everybody knows everything and I've done a great job. I don't believe in either one of them. So anyway, I am this time for sure done babbling. I'm going to put out my email address at the end. Again, Steve Bajork's link to his stuff. Do it, and hopefully I'll get a comment at the end of this, a like or a boo or something. So anyway, good luck. Good. Well, no, one more time. Soon we're going to move off of these text files, and we'll move over and try to do some, well, we're going to stay on text files, but we're going to do it in a new fashion. We're not going to start, that doesn't sound too good. We're going to get away from using this locate and put line. We're going to recode them. We're going to do them ourselves. We're going to look at the memory layout, the MMU, how it works, and where we'll be mapping stuff in. We'll be mapping the high-res text screening down in low memory. When it's down there, what we can do with it, how speed things up. So that's coming very, very soon. So get up to speed to where all this stuff, you understand it. Again, if you don't understand it, ask questions. Okay, let's take a look and see what our code did. We changed. Get on the right screen. Here we go. All right, looks exactly the same as it did before. No changes. Now, if I hit the B, we immediately get that line 4 is blinking. Now, if I hit the N key, it quits. Again, B, N for no blank. Now, if I want to change the text, I hit the T, and there's our new text. We didn't code in revert back to the old text, but so if I hit the T again, it's just going to stay there. But I can hit the B, and we'll get it to blink, and N to not blink, and Q to quit. Now, if we want to reset this, we'd have to reload the program to get to correct the text. So we didn't code in to refresh that. So again, blink, no blink, change the text, and quit. So what we coded works. Go ahead, modify it, and see what you can get. Okay, questions or comments, you can leave them in the comments below, and I'll get back to you. You can also email me with the address on the screen, or you can leave comments or questions on Discord, under COCO Discord, under Assembly with George J, and I will try to answer everybody's questions. So there you go.